All right, let's get started. Lights. All right, welcome back. So we talked about HTTP. So now you know the kind of the basic structure of HTTP and how it looks like, right? Request, response. Both the request and the response have headers and body. Maybe not the body all the time, but at least they have headers, some metadata. Okay. So and now you see the structure of the request is, what you're trying to get, but it's not always get. So we'll talk about in a later week about these different verbs. Get simply means I want a resource, don't change anything, just give me something. Okay. We will see other verbs when we want the server to change things potentially. And then the response starts with usually the status, like how did it go? Is 200 okay? 300 go somewhere else. 400 it didn't work. Your fault. 500 something it didn't work. My fault. Okay. So this is what the response looks like. All right. Great. All right. Moving on. So and you have this website HTTP statuses in case you're ever curious about the statuses. Let me mention a couple of things about one thing about status. It's really important and useful to give a very accurate status message. All right. And I'll show you instances later this semester where the difference can be kind of critical. So don't be casual, really debate, like, is this gonna be like a 200 or a 201? Like, it makes a difference, all right? And I will talk later about why it makes a difference and why we want to find the one that is just perfect for each situation, all right? And why there's so many of them for that matter. Okay, so now that we know all that and we know like the basics of the HTTP protocol, we're going to make an API this week, which is going to use HTTP to create data and return data to users. All right. So this week, essentially, you will start making the API for your project idea. A team asked me during the break, "Hey, which project idea?" We have a couple. Pick the one that your team is the most excited about right now. I assure you that even though you may feel like this week and next week, oh my God, we're doing a lot of coding, but actually that coding is really easy to change, okay? So you still have, let's say, a week or two to change your project idea, but I want you to get started in some direction. And I'm going to ask you to make a very, very basic application, API web application for this week, all right? Okay. And again, a reminder that the database we're going to use is just a local file system. We're just going to store some files in a folder, and that's going to be our database for this week. All right. And in coming weeks, we'll see why that is clearly not enough. All right. So let's talk about how to make a web application with Ruby. All right. A few moving parts that we need to kind of understand and discuss here. All right. So I'm on slide 9 right now. So let me just describe a few parts of our API of the server that we're going to create today. Okay. First of all, the part we're not going to create, obviously, is the web client. Like the person talking to your application. It could be a mobile application. It could be a browser. It could be a command line application, right? Like you just saw me do with GitHub's API. It's some kind of client who's going to make requests to us over HTTP. So we're not going to write this part. That's assumedly like a device or a software that's already out there, like a browser. Okay. So web clients are the external applications that make requests, like a browser or whatever it is. Okay. All this part, these 3 layers, are parts of our web API, as part of our server. All right. And let me just describe what these parts are. You're not going to be writing each part. In fact, you're going to be writing something even below these things. But I want to explain to you these moving parts, okay? So first of all, we're not going to write an HTTP server from scratch. That would be crazy. It would take way too long. HTTP is a known protocol, so there's already plenty of web servers which we can use that speak HTTP and can interact with Ruby applications, okay? So we typically call these like Ruby web servers. These are applications which can talk to clients, get requests, send back responses in HTTP, and in turn, they can, on the other side, they can also interact with Ruby code. All right. Some examples of Ruby web servers include WebBrick, Puma, Fin, Unicorn. There's a ton of them. Okay, the one we're going to use in this semester is called Puma. So Puma is not something you have to write. It's a gem that you can just download, and it acts as a web server. It can talk to the outside world and tell you, hey, you got a request. It can tell your Ruby code what requests you're getting. And then your Ruby code can tell it, okay, here's my response. Can you do all the stuff you saw before, like compress it, put in all the extra headers, and just send back the response. Okay. All right. But there's a whole bunch of options. We're just using Puma. All right. Why are we using it? Puma is a really powerful web server as far as Ruby web servers goes. It's a multi-threaded, multi-processing web server, so it can handle multiple requests from multiple sources. All right. So your application isn't limited to while it's handling one person's request, everyone else has to wait. No, not like that. All right. WebBrick is an example of a built-in web server that comes with Ruby, and it can only typically handle one request at a time. So it gets a request, and then your application has to develop the response, and then it sends back the response for you. In the meantime, all other requests have to wait. That's WebBrick. So we're not going to use that. We're going to use something called Puma. All right. Okay. And it can handle many, many, many requests. Great. Now the web application we're going to write, the API we're going to write this week, it has to take on a certain structure. It has to for every type of request, it has to have you've got to have a block of code in there, right? So if you're asking for the root resource or some other resource, you've got to define the different types of requests that can come in and what code you're going to write to respond to those requests, okay? To structure this application where you're going to write blocks of code for particular requests, we're going to use a web framework to organize our code. So web framework, all it really does is it helps you organize your code so that you can tell it, okay, for this request, run this code. For this request, run this other code, all right? So for different types of requests, you can write different blocks of code, and the web framework will help you kind of organize all of this, all right? So think of the web application framework as just some kind of structure to your application. And there's different types of frameworks. The most famous web framework out there is called Rails, Ruby on Rails, all right? We're not going to use that this semester. It's everything built in. It's very powerful, but I have some issues with it, religious issues, and we'll talk about. No, it's great if you're in a company, definitely use it. But yeah, religious issues, pseudo-religious issues. Okay. There's other ones like Sinatra, which is very bare bones. It hardly does anything for you, and you kind of really have to organize everything by yourself. We're going to use something in the middle. We're going to use something called Rhoda. It does a lot of things for you, but it doesn't do many things for you. So you have a lot of freedom to decide the structure of your application. Okay. With Rails, you have a little bit less freedom to decide the structure of your application, but I like a little bit more freedom. So we're going to use something called Rhoda. Also, Rhoda is extremely fast compared to compared to Rails. So it's a very fast web framework that, where requests coming into your application get to the right block of code very quickly. So it has a very nice way of organizing requests so that it can find the block of code extremely quickly. So it actually is much more responsive than other web frameworks. Okay. Just to let you know, though, you have other options of web servers. You have other options of web applications. Now, because the Ruby ecosystem gives you so much freedom, there's so many web servers, and there's so many web frameworks, it creates a problem. What would have to happen for these different servers to be able to talk to these different frameworks is that every framework would have to know about every single type of server. Like Rails would have to know about all the possible Ruby web servers and be able to interact and talk to all of them. That would be a huge burden on the Rails team. Like the people developing the Rails framework, that would be a big burden on them to keep up to date with all the different Ruby servers, okay? Similarly, all the different servers would have to know about all the different frameworks. It would be a big mess. It would be too difficult to manage such a complicated ecosystem. So what the Ruby ecosystem does is that the Ruby language comes with a very basic library called Rack. And what rack does is it provides a interface to which any web application framework can talk and any web server can talk. All right? So think of rack as a common language between all the Ruby servers and all the Ruby application frameworks. All right? So now Rhoda or Rails, these application frameworks, they don't have to know anything about the server they're going to talk to. They speak in a language that is a common standard called rack. All right? And then the web servers, they also know how to interact with this interface called rack. And because they both know how to talk to both sides know how to talk to the same interface, we can now use any server, any web server, Ruby web server, and any Ruby web application framework. All right? So these are just some moving parts I want to tell you about. So when a request comes in from a browser, this is a browser on the screen. When a browser sends a request to your web API, it first goes to Puma, it's the web server. All right? And Puma says, okay, I talk HTTP, I'm getting an HTTP request. And it says, okay, I need to send this request to the application that the developer wrote. That's your code over here. Okay? But how does it send it to you? What format should it send it to you? How should it organize the request? Well, it doesn't have to know because it reformats the request into a common, if you will, syntax or language, which we will call rack. All right? Your application is part of a Rhoda web framework, and that will also talk to rack and say, if there's a request coming in, tell me. Okay? So the request goes to Puma, Puma sends it to rack, rack changes the request to the format that a web application framework can handle, and Rhoda, a web application framework, will then take that request and it will send it on to your specific code. All right? So that's the way, and the response goes the same way. When you write your code, you say, okay, I want to send back to the browser, blah, 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 some data and some metadata. That goes to Rhoda. Rhoda reorganizes it, restructures it for rack. Rack restructures it in a way that Puma will understand. All right, and then Puma sends the result back to the browser. All right. So essentially, what I'm telling you is the requests and responses. Your code that you will write, you will not see the raw request coming in over HTTP, because then you have to manage many other network-related stuff that we don't want to get into this semester. Okay. Instead, there's many layers that are distilling the request into a way that is easy for your code to understand. And when your code produces the result that you want to send back, it goes back to the same layers that restructures it back into a way that the web browser will understand. All right? Okay. This may not seem very concrete right now. We'll see examples of this as we go throughout the semester. All right? But just to let you know that these are the layers that are working. So let's go ahead and make a Ruby API server, shall we? With all these moving parts, with like Puma, rack, Rhoda, all this stuff, okay? So let's develop it. So we're going to, for today, we're only going to develop this part and the database that goes with it. We're not going to make the web application or the, anything else, all right? Okay, so the way you'll begin is you'll make a GitHub repo for your team, and you'll make a folder structure that looks something like this. Okay, you'll make a project folder, and in your project folder, you will have files that look something like this. I'm going to go through all these files slowly to explain what's in there. All right. You'll notice there's a couple of folders in here. App, that's where your application code goes. That's where you're going to do all your development, is in this folder called app. All right. There's also a folder called spec. Anybody knows what goes in here? Tests, yeah. We're going to write some tests to make sure our web API server is really working the way it's supposed to work. Okay. There's a couple of other files in here which I'm not going to cover, but you can look at my example code that I'll provide to you on Canvas to see like what I have done, and you can do something similar. There'll be a README file which will basically introduce people to what this API server is about. There'll be a license file. I encourage you to adopt a license. A license says, how can people reuse my code? All right? Under what terms can people reuse my code? You can take a look at my license, and I'll provide you more information about other types of licenses. All right? But it's typically smart that if you're going to put code online, that it has a license associated with it, telling people how they can and cannot use your code. Right? For example, maybe you don't want anybody to be able to reuse your code, but it's on GitHub. Well, you can make a license file saying you cannot reuse my code without paying me or something, without talking to me. All right. I'm using a license, you will see, that says anybody can reuse my code as long as you give credit to me, like you tell people it was my code. All right. But you can reuse my code. All right, cool. So I'll spend the rest of this class talking about all the files here, except for license and README. I'll talk about all these other files, and then after that, I'll talk about the actual code and the tests and what they look like. Okay? But I'm not gonna dive into the code until we talk about all the other setup stuff that we have to do to get this project going. All right? Cool. Any questions before I begin? So you will want to make a GitHub repo under your team's organization and call it something like, you know, something's API, the name of your application API. All right. All right. Let's go. So let's start looking at the different files that I'm using to make this project work. All right. First of all, there's the gem file. All right. I think you've seen gem files before in the previous assignments that you've done. This is where I tell Ruby, these are the gems that I'm going to use. These are the libraries I need to use to make this application. All right. And this is where it's coming from https rubygems.org. All right. And these are the gems that I think you will need for this week. Is going to be like JSON, Puma, and Rhoda. Again, remember, Puma is the web server. Rhoda is the web application framework, the structure of our web application. All right. And then there's mini test and rack test. You will need these for testing. This is something I use for debugging. You may not need it. Okay. And I'm going to have Rubocop because one requirement I'm going to have of you this semester is please every single week before you submit your final code, like before you push the final commit, your final commit to GitHub every week should be run Rubocop on your code and fix all the style errors. Okay. But as you will see, maybe, Rubocop does more than style. It also checks for some obvious security problems as well in your code, some very simple ones. Okay. RBNSCL, do we need that this week? I can't remember. Maybe, maybe not. I don't remember. We'll see. I have to look at my code again. Okay. But we will definitely need it later on this semester. That's why we spent so much time talking about it. Okay. You will also note here that I have told it what is the version of some of these gems that I need. Okay. Particularly for RBNSCL, Rhoda, Puma, but you could do it for the others. I've told it what is the version that I want. I'm using this style where I'm telling it this looks like roughly version 5, right? Like looks like kind of like sort of version 5. Let me just tell you what this means. This means this tilde and greater than sign and then the number basically tells Ruby or tells Bundle what is the major version it should stick to. All right. Oh, it should be 7. This should be 5. Sorry. Or maybe this. Look at this example right here for RBNSCL. This this tilde greater than 7. It basically says I am happy to use version 7 point whatever. I don't care. All right. That's what it tells it essentially. Once I've set up this gem file, I'm going to run bundle install, and bundle install or just bundle will install all these gems on my computer. Remember, bundle does not install these in your project folder. It installs them on your computer in a central place so that other projects can reuse the same gems. Okay. But within your project folder, bundle will create a gemfile.lock file. All right. And in this file, this is created by bundle. It will write down exactly what version of each gem it installed. Now you see some of these gems, I didn't ask for them. Like I asked for JSON and mini test, but what's AST, code ray, FFI, method source? These are gems that other gems needed for some reason, so they got installed as well. All right, and so on and so forth. Okay. And you want gemfile.lock to be part of your GitHub repo, part of your Git repo. Because if anybody else was to clone your code and run bundle, you want them to get the same gems that you are using, because you know your application works with these versions of these gems, right? You don't want them to get different versions and then something doesn't work for some reason. So you want gemfile.lock to be part of your Git repo. Are you okay with this so far? Okay, cool. Any questions on this so far, just on the gem file? Yeah?
Can we just change the gem file lock for any version?
Good question. You should not change the gemfile.lock. You should not edit it, because bundle assumes it wrote it. So you don't want to introduce some error. If you want to change a version in here, you should change it in your gem file. There's other ways of specifying version numbers other than this. You can Google it. So you can specify, if you want a very specific version of a gem, you specify it in gem file. Gemfile.lock is a manifest. It tells you what was done, not what you want. Okay? Good question, Riley. So gemfile.lock should never be changed by you, because it's a report by bundle on what it did. It's not what it's going to do next. Okay? But anybody else who downloads your application, when they run bundle, it will look at gemfile.lock to follow the exact version numbers. Okay? All right. Then you saw that I've got a whole bunch of dot files. By dot files, I mean these files that begin with dot, with a period at the bottom, like period gitignore, period rubocop, period ruby version, etc., okay, with a dot. Let me explain what some of these are and why you need them in your project. All right. First of all, let's start with Ruby version. You've got to decide on which version of Ruby this application is going to be written for, because some of those gems may work with certain versions of Ruby but not with others. So you've got to be careful. All right. So in my case, on my system, on my computer, I just installed version 3.0.1. This is the newest version of Ruby. It just came out, I think, some weeks ago. So if you have not installed it, I would suggest just switch to 3.0.1. The 0.1 is a patch version. It tells you that they fixed some problems with it. Okay. Then I use this command, rbenv local 3.0.1. All that does is it creates a little file on my project folder called .ruby version, and it says this project will use version 3.0.1. Now, every time I move, like I use CD and I move into this folder, RBENV will quickly, automatically switch to Ruby version 3.0.1. All right. Any questions on that? We played with that in the beginning of the semester, RBENV. Okay. Couple more. Let's look at gitignore. So gitignore is a file that you can make where you can tell it files and folders that you do not want Git to store. You want Git to pretend these files do not exist. Okay. For this week, we're going to put some files. Our application will create some files as its database, and it will put it in this folder app/db/store. So I'm telling .gitignore, I'm telling Git, do not store my database files in the Git repo, because those can change anytime. All right, that's just data files. Do not put them in my repo. All right. Any questions about .gitignore? You're okay with this? All right. Now I warn you, when you're using some tools like Bundle, Visual Studio Code, a lot of these tools will start putting their own files into your project folder. It's very annoying. Like if you use Visual Studio Code, it'll make a folder called .vs code, and any settings that it thinks is specific to this project, it'll make a little settings.json for itself. Like, I didn't ask you to do that, but it does it. And I don't want this as part of my Git repo, because, you know, maybe another user wants different settings in their Visual Studio. Like, I mean, this is not part of my project, okay? Similarly, when I run bundle, it's going to create a little config file in a folder called .bundle. I don't want that as part of this project, okay? So what I recommend is you could put these folders, you could put them into .gitignore. But generally, some folders like .vs code, .bundle, you don't want them in any project, not only this project. So my recommendation is in the home directory of your Unix account, make a file called .gitignore global, and this tells Git anywhere on my computer, never put these folders or files into a Git repo. All right, so I put .bundle, .vs code, and I said never put these into any Git repo anywhere on my computer. All right, so this is my recommendation. So make a global gitignore, or else you can put these into .gitignore if you wish. It's up to you. All right, both are okay. So these are a few of my dot files. All right. There's one more dot file I want to talk about, and that's rubocop yaml.rubocop.yaml. I want you to use rubocop every single week to make sure that the code that you're submitting, the final commit of your code, is like clean style. All right. However, there are some places and times where we need to modify the style a little bit because Rubocop doesn't know everything you're trying to do. There's some places where we're violating a style and we have no option. We have no choice. Okay. And some places where there might be a rule that is not always enabled, and I want it to be enabled by default. But I mean, I want it to be enabled if Rubocop does not enable it. Okay. So let's take a look at .rubocop YAML. So when you run Rubocop in your directory, in your project folder, Rubocop will look for a Rubocop YAML to see if you have modified the rules a little bit. So this is what I've got in here. I've got this section called all cops. So this is saying I've got some settings that applies to all the rules. First of all, I want rules that are specific to Ruby version 3.0. Because as Ruby as the language changes, it adds new features, and Rubocop also tries to catch up and have some rules about how to use those features. So I'm saying target version 3.0 means follow the rules of the Ruby syntax 3.0. Okay. New cops enable. It says there are some rules that are very, very recent, like they just got introduced extremely recently, and I want you to enable them. All right. Some people may disable them because they may feel, oh, those rules are like, well, we weren't prepared for those new rules. We have to change a lot of code. But you're just starting a project from scratch. So you can say new cops enable. It means if there's some new styles or rules that came across very recently, make them enabled as well. All right? New and upcoming styles. Okay? All right. It's also possible that there are some rules that are not yet officially part of Rubocop, but they will be soon. And you can say, yeah, please enable them right now so I can fix them before they become officially part of Rubocop. Okay. All right. I've got two more rules here. One is called metrics block length. There's a rule in Rubocop that when you make when you call a function, a method that takes a block, that block cannot be more than 15 lines of code. It's a style rule because it says if you're writing blocks that are bigger than 15 lines, maybe that should be like a class or a method by itself. Like that's too long for a block you're passing along. It's doing too many things. Okay, and I'm telling Rubocop, yes, enable that rule. That's a good rule. Except, exclude means except. Don't do that in my test files. In my test files in Minitest, I have to create very long blocks because that's the syntax of Minitest. So for my tests, don't look at this rule. For my main code, enable this rule. It's fine. Okay. Second, YAML load. Remember, we talked a long time ago about YAML is kind of a dangerous tool because it's possible to give an application some YAML data, and when it loads it, the application will try to make a Rail object out of it. All right. And that's dangerous because somebody could force you to create an object you didn't intend to create. All right. So by default, Rubocop tells you do not use YAML load, use YAML safe load. It'll only make hashes and arrays. It will not make like custom objects. That's turned on by default in Rubocop. Rubocop will stop you if you try to use YAML load. However, in my tests, there are times when I want to load a YAML object as a native Ruby object, not just as an array or a hash, okay? But it's just in my tests. I'm not doing that in production code, okay? So I've told it this is a good rule to follow, but not in my test code, okay? My test code, let me violate that rule, if you will, okay? Now, let me just ask you guys something, or I'll ask of you something, which is, don't abuse this Rubocop YAML file. If there are rules you don't like, don't just turn them off, okay? Discuss with the class. Send out a Slack message saying, I don't like this rule. What is this rule about? What is it for? Do I really need it? Let's have a discussion. Don't just start turning all the rules off. Because trust me, the rules were made by people with a lot more experience than you. You may not like them, but there's a reason they exist. And you don't want to be the person who's 10 years later kicking yourself for violating a rule that comes back to bite you, okay? So, all right. Any questions on any of these dot files? You're okay so far? Billy, you're okay?
Yes.
All right. If Billy's okay, we're okay. All right. So this is the basic idea behind some of these setup files in the root directory of my project. All right. Yes, Yenu. Rona. What's that?
Did you record the lesson?
I did. Yes. Ed, can you confirm it's recording? Yeah, we're good. Yes. Yeah, good luck on that. All right. Is your computer's working? Okay. They had a little beverage related accident with her hardware yesterday. That was a scare. You were scared, right? Good. All right. Yeah. Take the bottles away. All right. Moving on. So, okay. Now I'd like to, before I get into my actual code of my API, it'll only make sense if you know what my API actually does. So let me demo for you what my API does. Let me run it and let's talk to my API and see what it does. And then we'll go into the code to see how it does what it does, okay? All right, cool. All right. So I'm going to run my API. How do I run my API? Like, how do I run this application? Like, which file do I run? So when you're running a Ruby web application, remember I told you it's got this kind of structure where like it's using, Puma as a web server, Rack as the intermediate layer that lets the web server and the application frameworks talk to each other. Then Rhoda down here. Who do I run? Like, what am I running exactly? So by default, but the way you run a web application in Ruby is with this command called rackup. Rack in the rackup refers to this library in the middle, rack. Okay? And it basically says, I want to run a web application that is based on this rack intermediate layer. All right? When you run rackup, rackup will launch your web application. How does it know what files to run? You have to make a little configuration file called config.ru. RU stands for not Russia, but rackup, okay? And this is a configuration file for rackup, and in it, you tell it, where is my code? What exactly should I be running? So in my case, I've told it, please requirements, please load my application code, which is in this folder. It's an app/controllers, and it's a file called app.rb. It's a Ruby file called app. Okay, so that's where my main code is for my web application. And then you tell Rack, please run the following object. It's called Credence. Credence is, you're going to see, it's the name of my application, and it's a module name. It's the name of a module. It's a namespace. So within Credence, there's a class called API that I've created. Please run this Credence : API. All right. There's some other things that are happening in here. .freeze.app. Dot freeze is just a Ruby method that you can call on any object, and it says do not let the code of this Ruby class change while it's executing. All right. Why? It's a security feature in a way. You don't want some other code that's running on your computer to be able to change your application code while it's running in real time. So .freeze says do not let this application change while it's running, okay? While the web server is running. And .app asks the Rhoda framework, please give me an object of this class. All right, so let me go run it, and I haven't shown you my code, but let me run it and we'll see what it looks like, okay? So over here, where am I? Okay, so let me do it over here. So over here, I'm going to run my server with rackup, all right? And when I do that, Puma, starting in single mode. Puma is my web server, all right? And how does Rack know to run Puma? Like, how did it know to use this web server? The way it knows is that Rack will look at which gems have been loaded into memory, and if one of them is a web server, it will use that one. Okay? So you shouldn't specify multiple web servers here, but it says, hey, I know about Puma. Puma's in memory. Puma's been loaded. I'm going to use that as the web server. Okay? So that's how Rack knows to launch your Puma application. All right. What else is in here? Minimum threads, 0 max threads. So it's got a little bit of multi-threading built into it. Environment development, I'll talk about that in a later week. All right. This is running, so in Unix, this is Unix process number 7609. So in Unix, on my computer, I can say, please show me, can I just say PS? Can you show me all the major things that are running, processes that are running? This is not all, but the major ones that are related to the user. So here it's telling me that you're running Z shell, you're running IRB somewhere. Where am I running IRB? I have no idea. I have to find it. All right. And here you can see this is my Puma server running. Okay. And it's got process number 7609 in Unix. All right. Cool. Where's IRB? Now I'm freaking out. I don't know what I'm killing exactly. Let's see. All right. Just kill it. Okay. Anyway, my process is running. So right now, I have my API up and running on my computer. Yay. All right. And I can actually access it. It talks on HTTP. So any HTTP client can talk to it. This is the address where it's running. 127001 just means local machine. It's running on my local machine. And it's running on port 9292. Why 9292? Well, that's a port that is not used by many applications. So Rack just chose that port to run so that it doesn't conflict with any other services running on my computer. Okay. Later on in the semester, I'll change that port number to like port 80 or whatever a web server should run on. But for now, it's running on a temporary port called 9292, where typically we don't expect anybody else to be listening in. All right. Okay. So can I just access my server from this IP address and port? I should be able to. Let's do that. So I'll first try it on my browser. Okay. I'm going to first go to my browser. And here, I'm going to just paste in the URL. Are you ready? I've pasted in the URL. I haven't hit enter, so I haven't yet called my API. All right? Nothing called yet. Fingers crossed. Let me enter. Boink. My browser automatically switches to JSON mode. Firefox knows that this is JSON data and says this is JSON data And the JSON data says message credence API up at /API/v1. So it's getting something back from my API. All right, it's sending back a JSON message. Back on this side, you'll notice my server has now told me, hey, I got a request from this port number, happens to be my local machine as well, and it made a request at this date and time, okay, time zone. The request it made, and this is the first line of the HTTP request. This is the first line of the HTTP request. It says, somebody's trying to get the root resource using the HTTP 1.1 protocol, and it tells me the result was 200 OK. All right. This 39 says this is how many bytes of response I sent back. And this, I believe, is how long it took. It took me about 2 milliseconds to respond to this request. All right. Cool. Let's break it down and see the full HTTP request and HTTP response. All right. Actually, do I have them? I think I have it here somewhere so where I can just copy and paste it. Okay. Where's my terminal? Terminal, where are you? Terminal. Okay. So now in another terminal window, let's pretend this is another machine. Okay. Just bear with me. And I'm going to make a request to my server. The request is going to be the same request that the last machine made. I can use 127.0.0.1, or the nickname is called localhost. It means the local machine. Okay. All right. And the resource I'm asking for is just the root. I don't have to put the slash. It means, like, if you don't give it, it means the root resource. Okay. And let me hit enter, and let's see the full request and the full response. Bang. Here is a request that got sent. The request is get the root resource. Okay, I accept everything. You can compress it if you wish. Keep the connection alive. Who's talking? HTTP. Here's the response that got sent back. 200, okay, yep, I got what you were asking for. I'm sending it back to you as for a JSON application to process. All right. And a space, a blank line here says that now that's the end of the headers. The body of the response begins. The body of the response is this JSON text. Okay. I'm sending back a message saying the Credence API, Credence is the name of my application. The API is up and running at API/v1. All right, cool. Let's send a more interesting request. So now, by the way, it said it's up and running at API v1, right? So let me make another request to where it told me it's running. It said it's running on /API/v1. This is the path where the API server is listening to requests. So let me go to that path and see what it says. Oh, I go to that path, and now it says 404 not found. So my API is here, but it's saying I don't know what you're asking me for. I cannot find it. So I have to ask it for something, and it just so happens that after reading the documentation, I find that the request that I have to make is actually this one. I'm going to ask it, tell it, look, API, I know that you're holding a whole bunch of important documents. Can you please give me all the documents? Documents is a word that my API knows to understand because I wrote it. All right, so in your project, it will not be called documents, it'll be called something else. All right, but in my project, I've got a project that's storing some documents. So I'm asking it, can you please give me those documents? Let's hit enter and see what happens, okay? So here's the request. Please get for me API v1 documents. All right. And here's the response. Whoa, look at this. Cool. It's saying 200 OK. I got all the documents. All right. Here's some more headers. It's saying the length of the data I'm about to send you is 80 bytes long. I'm sending application JSON. Here's the body, JSON. And my body is saying, here are the documents. I've got documents with IDs this, this, and this. All right. And I don't remember the structure of my own API, but I believe I can take one of these IDs and I can say, please get me documents slash and this ID number. Okay. Hey guys, you paying attention? All right. Okay. And then this tells me the actual JSON of the response that comes back. And in this case, this is an actual document with ID number, da da da. Where did it get this document from? My database somewhere, obviously. Okay? Cool. Meantime, on this side, on the server side, you can see all the requests coming in is logging them all. This is your server log. All right? So this is the log your server is keeping of all incoming requests and what it's responding with. All right? In this case, it's showing you to screen. Most web servers will save this to a file. All right? But right now, I'm not saving it to a file because it's going to standard out, I think, right now. All right? But if you are a web administrator and you've ever run a web server, you will know that there's a file where all this records are kept. Okay? And that's importance. These records are typically kept on the server somewhere. Why is that important? Is there a security issue here? It means if you are making a request with some URL, that URL is stored in a file somewhere. If there's any sensitive information in that URL, it's stored in a file somewhere. All right, so we'll talk about why that can be dangerous in coming weeks. What's the question?
In the URL.
Yeah. It's basically, it's you notice this stuff. Where is this coming from? Where is this information coming from? This was the information in my URL, right? Like when I said what's the request I want to make, I said localhost 9292, and this is part of the URL. Okay.
So when you make a post request and you send it in a form or something,
Good question.
they save that?
We'll see it.
That's in there?
We'll see it in a different week.
Okay.
I want you to lose some sleep about that. Great question. All right. All right. Okay. So do you see what my application does now? It can take requests for documents. If you just say /documents, it'll return to you ID numbers of all the documents that are there. If you say documents / and then an ID number, it returns to you an actual document. You good so far? Yeah? When I say, are you good so far, you're supposed to say,
Yeah.
200, okay. 200, okay. All right. What else? Let's do a more complicated one. Ooh, this is gonna be a little hairy. Let me first put it in here so that I don't screw it up later. Right. So now I'm gonna send an extra big request. All right. This time, I'm using the HTTP command line application. All right. And you see --JSON. I'm telling it the HTTP application that I'm going to send a JSON request this time. Okay. And Tara, we're going to do a post request on your request. All right. So we're going to do a post request this time. This is different from a GET request. I'll go into the nuances of them. The basic idea of the difference is that typically with a post request, how's it different than a GET request?
You're sending information.
You're sending information.
That's going to change. Can be stored somewhere.
Right. So a post request typically means, actually you don't have to send any information for a post request. The second part of what you said is the important part. A post request says, I am now asking the server not to give me something, I'm asking it to create something. All right? And there's a nuance even higher than that. We'll get to it in a later week. All right. So I am going to, and I'm going to send this post request to, HTTP localhost 9292 API v1 documents. And what I'm passing it here now is a whole bunch of data, like file name equals this, description equals this, content equals this. And I'm telling the HTTP client, please make that data in JSON format. All right. Please send all this extra information. So I basically am asking my API to make a document for me. A document with this file name, another .yaml, this description, and with this content. Okay. Now I'm not writing it in JSON format. Instead, I'm asking the HTTP client, please make it a JSON object for me. All right. So let's run this and see what happens. All right. So here we go. I'm going to run all that. Okay. Bang. First of all, let's look at the server side and see what it tells us. It tells us somebody just made a post request to API/v1/documents. It doesn't say 200 OK anymore. It says 201. It's OK, and I created something. Actually, more specifically, I have changed something on the server side. That's what 201 really means. Like, I've changed myself. There's something about me that's different now. Okay? And we'll talk about why this relates to security in a later week. Let's look at the HTTP request and response. Now, this time, and for the first time today, my HTTP request actually has a body. Okay? This is the headers. I'm posting to API v1 documents. This time, the content type, I'm saying, I'm telling the server, I want you to send me back JSON this time, okay? And this time, I'm sending it a body. You see there's a little space in the middle, right? A blank line. And then I'm saying, take this JSON data and make something for me. And the JSON body is like this. I'm making a file with this content, this description, and this file name. All right? Cool. The API server responds to me by saying, 201, I've created something for you. All right? And it returns to me this little JSON, which says, here's the ID number of the resource I just made for you. And here's a little message it's sending saying, I've saved a document for you. Okay? So if I take this ID number, I should be able to request that document again. Bang, with that ID number. And here it is. This is the document I told it to create a moment ago. All right? Web API. Sounds good? Cool. Let me quickly show you the structure of the code. And I don't have much time. I'm only going to take 20 minutes to show you the general structure and the test code. I'm not going to go over it in detail because I expect you to go over it in detail and figure out how everything works and modify this for your own API's needs, okay? So by the way, what is this API for? What is this application for? Essentially, this semester, I'm going to try to make an application where teams of developers can submit sensitive files that they want to keep securely. For example, tokens for AWS or some other APIs or things like that. Usernames and passwords, not usernames and passwords, but like any setup information that is very sensitive and should be kept secret. All right. So I'm essentially creating an application where you as a team of developers can come and say, hey, our team has a file that is not on GitHub. It's a secret file with some secret information. Please store it for us so that each of us can access it later, okay? And only your team can access it. Other people should not be able to access it, all right? So for that reason, the key resource that I want to be able to store are secret documents, all right? Which I'm just calling documents. let's have a look at my code file. So within app, the app folder, I've got a controllers folder. I'll have other things in here as well. And within the controllers folder, I've got a file called app.rb. All right. By the way, that is the file that I told Rackup to run before. I said require app/controllers/app.rb is implicit. All right. Let's see what's in here. Actually, let me go straight to my code in Visual Studio. All right. Save, please. Close. Okay. So I'm going to go to my app controllers app.rb. All right. And in here, I'm going to run through this very quickly, just like in 10 minutes or less. All right. You notice I'm requiring a couple of things that I need, Rhoda and JSON. All right. Rhoda is my web framework, and I'm going to be doing stuff in JSON. I need that gem. JSON comes with Ruby, but it's just not installed by default, so you have to require it. Okay. And then I'm telling it there's another file that I need you to require. It's in another folder. Go back one folder, models document. Okay, and I'll talk about what that is later. Here is my application. My application, as a best practice, it's not required, but as a best practice, your whole application should sit within a module with the same namespace. So I'm saying I'm going to make an API class here, but put it within a module with the name of my application. My application is called Credence. All right, Credence is, it just means something you believe. All right. Here's my API class, and you'll notice, what does this do? Anybody remember? This is inheritance. You are inheriting from the Rhoda class. So I'm making a class that inherits from Rhoda. All right. It gets all the attributes and methods of the Rhoda class. So I'm making a type of Rhoda application, and I get all the methods that Rhoda has included in my class as well. All right. So this is called inheritance. All right. I think we saw inheritance way back when, maybe not. All right. So definitely in your tutorials you saw it, I think. All right. Yeah. Okay. So here's my API class. Okay. Plugins. This is saying there's some features of web applications which are not default part of Rhoda, but I want to load them. So these are little plugins that come with Rhoda applications. So one's called environments, one is called halt, and I'll show you at least how one of them works today. Actually, I'll show you how environments works right away. Configure is a method. You don't see it, but it's a method call, configure. Okay. Configure is a method that belongs to the plugin called environments. All right. And it's basically to set up the environment in which this application is going to run. I'll talk more about environments later. For now, I'm just going to use configure to run any code that should run before my API comes to life. Okay. Before my API starts running, any code that I want, any pre-set up code goes in here. Document is an object that I've created in another file I'll describe later, and I'm setting up my file-based database here. I'll show you the code for that later. Okay, now the main function that I'm running that Rhoda provides me is called route or root. Root or route? How many of you say route? How many of you say root? Use both. It depends. Okay. All right. So let's go with route for now. Majority wins. This is the big code block within which I am going to tell Rhoda how to handle the different types of requests that could come into my application. Routing here means how do you route the request? Like where should it go? Okay. So I call route, and it takes a parameter called routing, which has some information about the request that's coming in. Okay. Notice before I even begin routing, I have set, there's a hash called response, which Rhoda also manages for me. Response is going to have all the information that's going to go back in the HTTP response. Okay, so I'm telling this response hash, the content type header, please make it application JSON. All right, that is why every time I get a response from my API server, the content type is application JSON. It comes from me defining the content type in this response hash. Okay. Now I tell it, if somebody is coming to the root route, means the root of my application, you can then do this. All right, and you'll remember my root request was this. Oh no, not this even. It was this, right? If somebody asks for the root resource, then run this code. I basically create a hash and just convert it to JSON. Done. All right. And that's the code that's running to handle this request, and that's why this gets generated. Content type is set, this is created, this JSON body is created. Got it? You'll notice that I'm not telling it that this is the body of the response. By default, this block of code, this do and this block of code, the last thing that I return, the last thing that I do becomes the body of the response by default. Okay, the last thing you do in a block, in a routing block, is the body of the response. All right. You also note that I didn't say status is 200 OK. By default, the status is 200 OK. All right. I've got some, in my notes, I've got some information about what I'm talking about here. Okay. Now, that's the root request. For all the other requests, it goes through this routing tree. And this is a kind of tree. Okay. You'll notice that I'm saying, if you are on a route that starts with, /API, then do all of this stuff. All right. If within the API route you are on a route that begins with v1/, then do all of this stuff. So I'm nesting these routing calls one within the other, and this is a feature of Rhoda. Yeah, question.
It's just the wording is so confusing.
Yeah.
So by routing you were saying routing, right?
Routing, yes. Sorry.
Okay.
Routing, yes.
Because I was thinking of a root.
No,
Tree
sorry.
root.
Yes. This is root. This is actually
it's
tree
not the
root.
word, that's
Yeah.
why.
So routing.root. Okay, good. So if you're routing on if somebody makes a request that begins with /API/, then do everything within this block. And this is a huge block, and it's actually the rest of this file if I collapse it. Okay. Nested within that block, I've got another request saying, if you're routing on /v1 within API, then do this block. So here also I've got a block, I've got a routing within the API routing. All right. So this is how Rhoda manages the routing structure. Like folder by folder, you can specify sub routes. Right? And within v1, if you're routing on /documents, so in my comments I've got here, this is, API v1 /documents, then, and I've got another block here. All right, so this is all nested one within each other. And then finally, within this documents route, I say, if you've come this far, then you're obviously looking for API /v1 /documents. And if the routing request is a GET request with a string at the end, because remember, if I'm asking for a particular document, I will say / and some ID. So if it's a GET request to API v1 documents with an extra string / and an extra string, then do the following. What does it do? It calls the document class that I created elsewhere. It says, please find me the document with this ID number, convert it to JSON, and return that as the body of the response. Okay? And by default, the status is 200 OK. Now you notice something could go wrong, like an error could be launched. So I'm catching, this is like Ruby's version of try catch. I'm catching the error and saying if something crashes my application, catch it, all right? And instead of crashing, please stop the routing. Halt comes from the halt plugin that I defined earlier. This is a function that comes from the halt plugin. I'm saying halt the routing, stop, halt means stop. Stop the routing with error code 404, not found, and the following message, document not found in JSON. All right? Okay. And that's why if you go here and if you search for a document and I just make up a document ID, it will say 404 message document not found. It's all happening in here. Okay. I'm not done with this API v1 documents route. This block said if within API v1 documents you are doing a GET request with a string at the end, all right? You notice here I'm saying the string should be called ID. Let's just call it ID. Like temporarily just call it ID and then find it by this ID number, all right? So string called ID. What if you don't give me an ID number? What if you just do API v1/documents? So here I'm saying if the request was just a GET request with no extra / sub resource IDs, then call my document class, get all the documents I have, and return the ID numbers as a hash. Okay? But before I return the hash, I'm calling JSON, I'm calling the JSON library and saying pretty generate. This creates a JSON string with a really nice like structure to it, like tabbed in and everything. Okay? So that's human readable on the other side. Right? If I do .to JSON, it's going to return to me everything on one line. It's really ugly. So I'm saying make it a really pretty little JSON for me. Right? So that's what returns all those ID numbers that you saw before. Got it? And this is the last route I have. This is a post request within API v1 documents. All right? And here what I'm saying is, first, parse the body of the request. Because you remember, when I make a request to create a document, my request looks like this. Post API v1 documents, and then the body is a JSON block. Right? So what I'm saying in my code is routing.body gives you the body of the request. I'm saying take the body of the request, and it's a stream, so read says just read the whole body of the request. It'll return to you a string object. And I'm calling JSON and saying please parse this string object as JSON and give me a Ruby hash. So that's my new data. Is a Ruby hash with all the data that I was asked to create. Then I'm calling my document object, which I'll have yet to show you, and saying please make a new document with this data in it. All right? And then I'm calling this document object and saying please save the document. The save returns a Boolean, true or false, if it was able to save it. If you were able to save it, here for the first time I'm explicitly setting the response status. I'm saying set the response status to 201. Otherwise, by default, it'll be 200. Okay, 201 because I just made something for the user. I changed the server. I changed a file on the server for the user. So status 201, send this message the document has been saved with the ID number. If anything goes wrong in this process, return with a 400 error saying, not my fault, your fault. I could not save this document for some reason. What reason could it be? I don't know. Maybe it's not in JSON format. Maybe something else went wrong. But it's not my fault, it's your fault. That is all the code for my API. Just to handle a few different routes. And I'm going to ask you to do the same thing for your API. just not for documents, but for whatever. Pick one thing that you want to make, okay? Except, do not make user accounts. Other than that, everything else is okay, all right? So other than user accounts, make any other type of resource that your application would deal with. In my case, it's documents. In your case, it could be images, calendar events, etc., etc. Okay? Pick one resource, and I'm going to ask you to make like a few routes. One get route to get IDs of all the resources, one get route to get a specific resource, and one post route to create a specific resource. Okay? Where does this stuff get saved? Where am I saving all these resources? All of that is happening in a folder. First of all, where am I saving it? I'm saving it within app in a subfolder called DB for database, in a subfolder called store, and here you'll see all my text files. Do these text files look familiar? This is the ID number of the resources. Okay. From next week, we'll look at real databases, but for now, I want you to just like, so if you look at one of these, this is just a JSON file with like the data. Okay. Who's writing into here and reading from here? Not yet document, not my API code. This is document code that I required, okay? Let's have a look at document. So here's my document code. It requires JSON, base64, and RBNACL. It's, again, within the module called credence. I put all my important classes within the same module name called credence, okay? So that I know it belongs to my application, right? Here's a constant. This is the folder where I'm storing all the stuff. You can, by and large, use this document file yourself, just rename it to something else, and modify it as you need. Okay. Here's my document class. When you make a new document, you provide me the hash of the new document, and I basically look through the hash, and I do all this stuff. One little cool thing I'm doing, if you don't provide me an ID number, I'm creating a new ID number for you. Okay. How do I do that? I've got a little method down here called new ID. It's a private method. All I do is I take the current time and I encode it. Oh, I hash it and I encode it in base64. Okay. Actually, I hash it. I encode it in base64, and then I just take the first 10 digits of that base64. All right. What else does this do? Oh, when you convert a document to JSON, here's my toJSON method to convert it to JSON. All right? Document ID, file name, description, content, etc. Remember, when my application starts, I have a configure block where I call document.setup. This is the setup. All it does is it tries to find this directory where I'm storing all the documents. Remember this constant value up here? It tries to find that. No, not find that. It tries to make that directory unless that directory already exists. So if the directory doesn't exist, it makes that directory quickly. All right? What else? Saving, super easy. I just define the file. So the file will be in the store directory /id.txt. And what am I storing? I'm storing toJSON, means this object converted to JSON. All right. It calls this object's toJSON method. All right. So this is a method of this object type document. It says convert this object to JSON and store it in that file. That's it. If you're trying to find a file by an ID number, then I say, please read the file from this directory /id.txt, all right, and then parse it from JSON into a hash. All right. Oh, and take that hash and make a new document object out of it. All gives you the ID numbers for all the files. I'll let you read it and figure out how it does that. Okay, that's a little... I'm almost out of time. There's two things I wanted to cover. Quickly. Sorry, I'm going to go a little bit over time, okay? Base64, I haven't really described base64 in class before, but this is the structure of base 64. It's just another base format for data. So we have base 2, which is binary, base 10, which is, digital numbers like, 0 through 9, 10, 11, 12. Like the number system we normally use is base 10. Base 16 is hexadecimal. We talked about that before, right? Base 64 uses 64 different characters to store a value. And the 64 characters it uses is the numbers 0 through 15. Is the letters capital A through capital Z. After that, it uses small a through small z. And then after that, it uses the numbers 0 through 9. And then it needs 2 more to be base 64. It uses plus and forward slash. Okay. There's one little problem with base 64 though. When you encode some data into base 64, right, it could potentially contain a plus sign and a forward slash. And that's not very good for things like file systems and URLs, because slash has a meaning in a file name. Plus has a meaning in URLs. So for that reason, after base 64 was invented, people said, we need a safer version of this. The safer version is called URL safe base 64. That replaces the plus and the forward slash with a dash and an underscore. Okay. So if you look at my file names, well, none of these have any, well, at least I can guarantee they don't have a plus symbol or a forward slash. But this is a base 64 value. Okay. That's base 64. I've given you some sample code to play with where you can actually see how this URL safe encode and decode works. All right. The last thing is the tests. Again, I won't go you've written tests before by now, so I won't go through them in terrible detail. But I will mention a few things I'm doing in my tests, okay? So here's an interesting thing. To run my test, let me quickly run my tests. All right, I'm gonna kill my server. You do not need to run your server to run the tests, because we're gonna use a testing library that kind of simulates the server running without really running it, okay? And I'm going to just run my test by saying Ruby, there's a spec file called API spec, and that runs like 5 different tests and tells me everything is running, okay? Just to quickly go through my tests, and I'll do it here. All right, so here's my tests. I'm using a whole bunch of libraries. The library called rack test is important. This is what simulates your API running without actually running it on a port. All right, I'm loading my app, and I'm loading the models. I really don't need this line because this calling app already calls the document. Okay, I'm defining Credence API. This, the name of my API using a function. I'm just going to call it app. All right. All right. Describe. So here I'm running my tests. You notice I'm calling rack test methods. Rack test methods gives me some interesting functions that lets me simulate API calls. For example, here I'm simulating a request to the root resource by calling get/. Get is a function that comes with rack test methods. It simulates a call to my API, and it'll run that route in my API. Whatever comes back from my API is stored in my response from the API is stored in an object called last response. And I can call last response and say, what was the status message? It must be equal to 200. That's part of my tests. Okay. Let's look at my other tests. I should be able to get a list of all the documents. Notice I'm calling this a happy test because everything works the way it should work. So what am I doing? First of all, I'm creating some data and I'm saving it. You can look elsewhere in my code to see where I'm getting that data from. So I'm creating some sample documents in my database quickly first, okay? Then I'm calling API v1 documents, and I'm parsing the body of the response that comes back, all right? And I'm simply counting the number of IDs that come back to make sure it's the same as the number of IDs that the number of documents that I stored, which was 2. All right, that's all I'm doing. Here's another happy test. It checks whether I can get the details of a single document. So here I'm creating a single document and storing it to disk. All right. I am finding its ID number. And then I am calling my API with a GET request with that ID number. I'm checking, I'm looking at the last response body. And one of my tests is checking that the ID number of the response is the same as the ID number of the file I created. Another thing I'm testing is that the status message is 200 OK. All right. And I've got some sad tests in here. Here I'm checking, I'm trying to get a document that I've never created before. And that should give me 404. Here's the last happy request. I'm posting a request. I'm creating a document in JSON format. I'm posting it to API v1 documents with this header, information, content type application JSON. All right? And I'm just checking that the last response is 201, meaning I was able to create the document. I'm not actually going and seeing if the document exists yet, though. Okay. All right, cool. Last thing about my tests is you'll notice that before each of my tests, this before block is run before each and every single test. Before each of my tests, I go and I delete all the files in my document store. All the text files, I'm just wiping them out before each test. So each test starts with an empty directory. All right. One more thing, I've got a YAML file in this directory with some sample data that I can load to do my tests. Okay, I call that seed data. And essentially, where is it? App DB seeds. I've got a file with with a description of a couple of example data that I could store or write or read or something like that. Anyway, so for this week, I'm going to ask you to make exactly this. You can use my code. My suggestion is don't just clone my code and change it. My suggestion rather is just you can copy and paste bits of it or type it, but try to make it from scratch yourself. All the files and all the controllers and the models and everything. All right. You've got more than one person in each group, so please separate the work. I would like to see at least one commit from every person in your team if possible. Okay. So do coordinate your work a little bit like that. Okay. All right, great. So that is that. All right. So this week we're going to make a very simple API that can get resources and create resources. Just one resource. Don't go. In fact, do not go overboard. Do not make more than one thing because the code will change a lot in the future. And for the most part, you can copy and paste my code. It should work. Just not documents and not the structure of documents. Think about what is the resource that is most important to you. All right? Okay. Great. That's your assignment for this week, and I'll send out a description of that. All right? Thank you so much.